All right, welcome. Welcome, thanks for coming for this session. My name is Varun, Morgan here. I currently am a founder of a startup. I used to work at Google and helped incubate some open projects like gRPC and Istio.
I'm Morgan McLean. I work at Google. I'm the product manager for OpenCensus as well as a number of our Stackdriver products. So we're here today to talk about two highly related topics. OpenCensus, which is a tracing and application metrics framework that we publish from Google, and it's open source, and then also Istio and Envoy. And what we're going to focus on is the convergence between these. So being able to apply tracing and metrics and gather other types of signals from applications that are running inside of Envoy. We're going to start with a bit of a basic background on service development. So if you've been to other tracing talks before, you've probably heard this part, but hopefully you'll still have a few insightful things. So as everybody's very aware, the world is moving from large monolithic code bases to more highly distributed systems. Commonly, the term microservices is used to describe this. And so we wanted to give you an example just to really make it really apparent why distributed tracing is so powerful and why it's not just a technology that, while useful at companies like Google and Facebook and other really big firms, while it's useful there, it's actually really essential for everyone else. So if we look at a sort of older style monolithic application where you have perhaps a fairly small organization's code base, you might even have like a single app that's running, right? And so when a client request comes in and hits one of your APIs, it calls a bunch of functions, maybe then a database gets called and the response gets sent back to the person who called in. And that's useful, and we historically have had many tools that allow developers to inspect this. Whether it's traditional debuggers, running your application in a test environment, doing just plain old static code analysis in your IDE of choice, logging, system level metrics, etc. And these are things that the whole industry is pretty used to. I think most developers, probably almost everybody here, know that if you show up to a job at a new company and they don't use like basic things like whether it be like source control or like aggregated logs or things like that, you should probably walk out the door. And people understand this. But as we move into the wild world of microservices, there haven't historically been the same kind of tools available, right? And so if we think of distributed tracing, which allows you to track a request as it hops across multiple systems, this isn't just useful for latency analysis like it is at companies like Google and others who care very deeply about their latency. This is actually how you understand how your app works. In some ways, in addition to the latency benefits, it's almost like looking at a stack trace, right? And without a distributed trace with microservices, it's almost like trying to debug a problem without even having access to a stack trace in a traditional environment, which like no one would want to be in that world. And distributed tracing's up there with other technologies like profiling and debugging that, while they had a ton of applications and uses in your traditional monolithic code bases, we need to take a different approach when it comes to microservices. And this is what OpenCensus aims to target. So double-clicking on distributed tracing. This is a screenshot of Zipkin that I'm sure many people are pretty familiar with at this point, but it's an open source distributed tracing backend along with its own tracers. Distributed tracing gives us a number of things. It gives us the topology of our application, so you understand which services call which others for a given request. It gives you a view into how those requests are handled and a rough view of how much time is spent on each component of the request. And it lets you understand where the system is performing poorly, where errors are occurring, and also gives you correlation for other signals. So one really common thing with distributed traces is embedding those trace IDs in any logs that you collect so that you can see all of the logs associated with a certain request. And distributed tracing makes that much more easy and automatic than it would be just doing that on your own. OpenCensus also provides app-level metrics, which includes like latency metrics, RPC stats, at every level of the stack, as well as custom metrics. So I've given you a bit of background on distributed tracing, and again, like those of you who are already familiar are probably bored to tears already. But it's not necessarily an easy problem to solve, and this is where OpenCensus really comes in. So ideally, you want traces and stats to be automatically collected for every request that gets routed through each of your microservices. This is actually not that simple. I think Ben Siegelman just had a talk on open tracing, which is targeting the same sort of set of challenges. And the reason you see projects like these is that for distributed tracing, you need to have plugins or insights into every single web framework, RPC framework, storage client library, API client library, basically every single thing that can interact with or generate RPCs to get that data out automatically. You can do this yourself as a developer, but it's a royal pain, and most companies and most developers won't bother. So we need a better way of making this automatic. There's also a conversation around whether libraries, so like things that you link to your app, versus agents that sit and like do monkey patching or something else to get this data out, which of those is more useful? Agents can be very slick. You run them in the background, they automatically interact with your app. There are some challenges with that, which is why OpenCensus is distributed as a set of libraries. The biggest just being that we want to provide an API to developers, but also that it can be managed through source control. So if you want to add OpenCensus to your app, if you want to update the version of it or so on, you just do that through source control, make a new deployment. You don't have to mess around with anything in the images that you're using.
So what does OpenCensus really provide? If it wasn't obvious, OpenCensus is a single set of libraries for metrics and traces. So I think that's one key sort of takeaway. It does both. It's not just tracing. And it intends to be holistic in terms of correlating with logs and profile over time. So what is it today? It's a set of libraries in a few languages. The bold ones are where you have metrics and tracing available. The rest are coming. It already has integrations with web and RPC frameworks. So gRPC, for example, the plumbing is already built in with OpenCensus. Spring and some of those integrations with other frameworks is coming. A lot of the client libraries, so a lot of Google client libraries are being instrumented with OpenCensus. What does that really mean? So if you're a user, let's say you use data store library from Google Cloud, then you would have plumbings for OpenCensus already built in, such that when you are using it as part of your set of microservices, you get metrics and distributed tracing in a backend of choice already there without you needing to do work to instrument that. And there's more integrations of OpenCensus libraries happening. So I think Mongo is the one that's also already done, and there's more that community is doing in terms of integrating more libraries.
Yeah, we're focusing pretty heavily on these integrations right now because it's really important to get data from sources like Mongo, or I think we just launched Memcached and a whole bunch of others. We have a pretty big team right now that's just getting focused on building these integrations. So as a developer, you get these libraries and you get APIs for interacting with some concepts that exist in OpenCensus. So there's a few concepts of trace, spans, and tags, and we'll touch upon some. So span is an individual sort of call. There's a parent-child relationship between a set of spans. So let's say a request comes in from a user. It goes through a bunch of services. There's a parent span and then a child span. If it's calling 5 other services, that's like 5 other spans. And they collectively form a trace. I mean, these are basic in this image, it's each of the lines that you see in the Zipkin screenshot.
These are basic tracing concepts. And there's APIs for interacting with them in OpenCensus as a developer. The one other concept here is exporters. So when you have these metrics, you want to get them into, export them into a system of choice. So that is another set of integrations happening with OpenCensus. So Stackdriver. Yeah,
we support Stackdriver, Prometheus for stats, Zipkin for traces, Jaeger for traces, SignalFX for stats. There's a big list that's on the website. There's a number more. That's the ones I can sort of name off my head. But the nice thing about OpenCensus is that all of these things are baked into like the main library that you download. So when you link OpenCensus to your app, you choose the exporter that you want to use. It will automatically gather as many traces, spans, and stats as possible, and it will send those to your backend of choice. You can also use multiple. So we suspect like a really common use case will be using Prometheus for stats and then Zipkin or Jaeger for tracing. But if you want to go use every single exporter under the sun, you are absolutely able to do that. This is important for some companies where you had different teams that have used different tracing or stats backends, and you can continue to support that scenario of OpenCensus.
Right. All right, so one other very useful concept that exists with OpenCensus, and it's common at places like Google for any service developer to basically go to a service URL and say /trace_z or /var_z or /rpc_z. And that's an extremely, extremely useful concept to be able to go to any service and get a pretty standardized set of real-time, unsampled metrics. So you're having some problems. This is actually your first behavior is, okay, let me check the /rpc_z page and look at the list of what were the last few RPCs, what were their latency times, what were the error samples, and you can actually click on these to get to the individual requests. And you can look at the trace IDs and span IDs for every request that were generated for every incoming request, right? So again, extremely useful concept, which is built in as part of OpenCensus.
So the OpenCensus client libraries each host. It's optional, but they host these pages. They have a little web server built in. And so you can go there and get just the fire hose view of all the spans and stats that are going through a system. Traces are generally sampled, often at like a very low percentage, like 1% or fewer. This gives you data to everything that doesn't even get sent to your backend. So if you're debugging a critical production issue, these Z pages are incredibly useful, and this is built into OpenCensus.
Cool. One more very useful concept in OpenCensus is tags. So imagine, again, you're doing the analysis, but you say, okay, I want to I want to get a subset of latency or some other metric or set of traces for a subset of requests, which is only client equal to Android, or only for user agent curl requests that happen, or for given IPs and so on. So you can add tags, which is basically dimensions in your code. And you can basically define your own dimensions and get your metrics by those dimensions. So if you define tag equal to client, let's say mobile client, then you can get your metrics by mobile client, right? So very useful.
Metrics and traces or any other telemetry, yeah. And so this is a great way so that you can sift through data on your backend. So I can talk about this. So this does seem like a somewhat self-serving slide, but I can explain. So at Google and not just Google, but other large web services companies, we've been using these technologies for a long time. These are basically how we've been able to manage reliability and performance at extreme scale, and how we've been able to reduce our root cause analysis time for errors and keep our latency very low. And so at Google, a lot of these technologies have been built in. So I mentioned earlier that collecting distributed traces on your own can be quite difficult. And at Google, it's not, mostly because the various frameworks and technologies that we use inside of the company have these concepts of tracing built in. In fact, for most Google services, as a developer, you don't have to do any extra work to get traces. And so this sort of fits with the theme of things that you've seen generally from Google and other vendors of releasing the same platform components that have made themselves successful open source through bodies like the CNCF or others. Right, so like at Google, like the things that allow us to get tracing automatically include not so much Borg, which is externalizes Kubernetes, but the internal variants we have of what are effectively Istio Envoy and then gRPC. Right, so at Google, for example, our equivalent to gRPC internally is called Stubby. Stubby effectively just collects traces automatically, so if you write a service, even if you've done no extra effort, you can get distributed traces and those automatic application level metrics from your service. In part by open sourcing OpenCensus, which is kind of boringly just called Census inside of Google. We were a little less creative with the name. We are trying to expose this same technology to developers everywhere. Obviously, we have an offering in the market with Stackdriver, but to be blunt, like Stackdriver is not the reason we're open sourcing OpenCensus. It's actually funded from an entirely different division in the company. It is mostly just so our own customers can be more successful on GCP, but also so that customers who call into our APIs and want to get traces and metrics or have problems with those APIs have a way of getting it. And so we're trying to externalize this throughout the industry so that getting traces and metrics becomes really ubiquitous. So that when we are debugging a customer issue, or even other cloud vendors or other API vendors are debugging customer issues, they can do it much more effectively.
All right. The talk was about another piece. So just a caveat, I mean, these are a little bit forward-looking. A lot of this is not done, but planned. So I believe people, I mean, there's been a ton of talks around Istio, so we don't need an introduction to that. But if you do use them together, and we think the two together are very useful. So, and why is that? So one is you want to integrate, you can get your OpenCensus libraries integrated into, let's say, new things you're developing, or languages that are supported, but what about others? And we think having a sidecar model, which Istio allows with Envoy, is actually a very useful one when you want to have everything instrumented in your system, and the whole point of tracing is that everything is instrumented, so you can go end to end. So when you do have envoys sitting next to services as sidecars, you would imagine like there's configuration for Envoy stats for what needs to be measured. So whatever the metrics are, so you need latency, error count, those are configured as part of Istio configuration, which drives Envoy configuration. You can get application level as well as Envoy level tracing into a backend of choice through exporters. So notice that you can get in-process application level metrics and tracing through a library approach, whereas for in Envoy that's a little bit trickier to do that. So you can get both in a world that you have OpenCensus libraries and envoys. The other piece that exists in Istio, for those of you familiar with Istio, has a piece called Mixer, which is an aggregation point, which is basically also the policy injection point. And you can imagine something like an OpenCensus adapter to Mixer to enable sort of the exporters to be, to enable basically your backends. So let's say you use Zipkin or Jaeger, those can be integrated through a Mixer adapter. Mixer basically is a central service for those familiar with Istio, and basically every envoy which is sitting next to every service can report metrics to Mixer, which can write to the through OpenCensus adapter to the tracing backend of choice.
That has a couple of benefits. So when you're using Mixer, when it's aggregating your traces and metrics, with OpenCensus, it's nice because the exporters are configured in Mixer, so it's you configure it once effectively. But also, each of your nodes isn't sending data directly to your backend; they're sending them to your Mixer, right? So you don't necessarily need those nodes connected to the internet if you're using a backend that's hosted somewhere else, which can be nice for security, depending on how your application's laid out. And you're also just centralizing a lot of that traffic through one place. Longer term, it's also going to let us do probably some pretty interesting things where, for example, we might do like subsampling on the Mixer. So you'll collect more traces from each node, send them to the Mixer. We might pick and choose which ones are more interesting to then get sent to your backend for archival purposes. And so it opens up a number of really cool possibilities once we're sending this data to the Mixer, aggregating it there, working on it there, and then sending it to the backend.
Yeah, and you could do aggregation and other kinds of sort of post-processing at the Mixer layer. And then the other thing which is in Istio, application, it's not fully automatic. Like the application does have to forward headers for every request to Envoy. But in a world of OpenCensus libraries, they could do that job instead of you doing that job. So that's another sort of ease of use thing when they're integrated. So the question you should be asking is, okay, so I thought Envoy provides this, so why do I need these two together? So there's a few things that are obvious, which is a bunch of features. So features which OpenCensus brings, which is the /z pages, which is the ability to create custom tags. Those are just features that don't exist without OpenCensus, right? The other is correlation. So a big value in tracing is being able to correlate that for a given request, what were the spans that were, what was the trace context and what were the spans that were created, and correlating that and seeing latency for every hop. And that correlation is something that you would have to do yourself in the absence of an OpenCensus library. Also, a lot of the automatic spans that we spoke about when you're using client libraries where OpenCensus is integrated, you would have to you would not get that in a world that there is no OpenCensus, right? So you can use, so if you integrate with OpenCensus, you get app-level instrumentation and tracing, whereas for additional spans, you can use the built-in Envoy tracer. So it would look something like this, and again, this is not done, but planned to be done. You would have an OpenCensus library integrated with your actual code. Probably have Envoy sitting next to it if it's part of Istio. And each of them can be sending metrics and trace data to the backend that you configured. It could be, the interesting thing is it could be through Mixer or even direct.
Yeah. Yeah, my understanding is that this actually works today. There's a demo we did in February for HTTP, but if you're using gRPC, we still need to fix that. We're making some pretty big investments into Istio and Envoy support for OpenCensus over the coming months.
I mean, just wanted to show what it looks like to make it a little bit real. So if you do use OpenCensus, so there's a, is it big enough? Yeah. So this is a simple hello world code for using OpenCensus Go library. So notice you just, all you're doing is just basically using the OpenCensus gRPC library. You are registering an exporter. So there's a concept of exporter with OpenCensus, which is where do I want my metrics and traces to be exported? So you register them. So in this case, Prometheus exporter is being registered for metrics, and Stackdriver exporter is being registered for trace. So it's a simple API call to do that. And then there's a bunch of predefined metrics. So you say, OK, for OpenCensus, I want in my view, which is the metrics, I want round-trip latency view, and I want error count view, right? And those should be registered, and that's about it, right? There's a whole bunch of others that you could. And this is the one that gives you the Z pages. So there's basically starts up a simple HTTP server, which can show the /Z HTML page that we were showing in the slides before. So that's basically simple OpenCensus Go library into a hello world code. Okay? So when you do that, you actually, and in this case, we registered to Stackdriver for trace.
Yep. And metrics. Just for this demo.
Just for this demo. OK. Yeah, so we did both Stackdriver. All right.
Yep.
So if you go look at metrics, so you get, basically without you doing anything, you do get P50, P99 sort of latency. This is just like hello world, say hello method, gRPC method on client and server. So, and if you're, this is just randomized on sort of request sizes. That's why it's all over the place. But these are graphs you can get sort of without you doing any work. And in this case, and you could get it in the backend that you desire. So including error count, round-trip latency, which we registered in our code, request and response bytes, and of course, counts.
And all of these metrics you see here, these are automatically captured by OpenCensus. You don't have to write code and define these. These are ones that OpenCensus pulls in. You, of course, have APIs to go and define your own metrics and send custom metrics.
Right. So that's metrics. And then you can, looking at tracing. Yep. So this is, we registered Stackdriver trace. So this is looking at a bunch of tracings. So you have your first, this is your actual trace with a sort of one span. Just, you sent hello world. It took so many milliseconds, so many bytes sent. It received, and so often this is in a complicated call flow graph. Becomes an extremely useful tool to say which service, which method in that service took how much time, and where is the bottleneck. So it becomes a very, very useful tool in complicated scenarios. Also, when you have, you can go look at any given specific requests at a given time. You can look at simple things like how many RPCs, what duration it was, and this is coming from OpenCensus Go agent. Anything to add here?
We're good. Let's go back to the presentation.
Yeah. All right. So this code is available on GitHub at that link if you want to play with it yourself. All right.
So we have a lot of things that are coming forth, both for OpenCensus as well as OpenCensus with Istio. So when we look at sort of the title of this talk, Istio and OpenCensus, and the things that are focused on that, we're completing our support for Envoy, and then we're going to be making some pretty big investments into new features that'll be accomplished via the mixer. So that's the aggregation and perhaps like subsampling and other things that I talked about earlier. When we think about just OpenCensus on its own, which includes OpenCensus and Envoy, but just OpenCensus really running in any environment, we have a lot in the pipeline. The first is just more integrations. So right now we have like MongoDB and a number of other databases. We're building integrations for various web frameworks. I think we already shipped gRPC, but for Spring and other web frameworks across various languages, so you can get those automatic traces and perform correlations completely autonomously. Next, we're also finishing our library support across all 8 languages. So right now we have tracing and metric support for C++, Go, and Java. We have tracing-only support for Python, PHP, and Ruby, I think. And we're going to be building support for .NET and Node.js. There's also some community-contributed libraries, so I think we actually technically support like Erlang, for example. And that's just a large community contribution. Next, longer term, we're going to be focusing on client-side instrumentation for mobile and web apps. So today, most distributed tracing solutions focus on back-end tracing, so tracing requests as they hop between your microservices, but that doesn't actually give you a good visualization of client-side latency or like the causes of the latency that your customers are experiencing. For example, if you get a customer who complains that your website is slow and it's just not fast enough, it might be that they're just on a really slow internet connection, in which case there's not much you can do about that. So by building in support for mobile apps, web apps, desktop apps, you'll be able to get traces that actually start with the client request. Next is something we're calling more intelligent sampling. So traces these days are generally sampled somewhat randomly. Sometimes it's percentage-based, where your application might just sample like 1% of traces or something like that. Really, what you want for distributed trace sampling is to sample requests that are interesting, either those that are slow, those that have errors, or those that are correlated with some other interesting event. And so we're making investments into features that we call like retroactive tracing or deferred sampling to be able to capture traces or perform that sampling decision partway down the stack. So that you can still get a full trace, but your traces might be skewed towards higher latency requests or requests with errors, which is really, really powerful. If you're not as familiar with tracing, it might sound like not that compelling, but generally most of the traces that you view in basically any tracing system aren't that useful because they're describing the average customer request. They're useful for understanding topology, but not for chasing down the root cause of an issue. With more intelligent sampling, a higher percentage of your traces will actually be interesting and actionable. Finally, our big long-term ambition for OpenCensus is for it to be the library that you use to capture like basically all of your application's telemetry. Today we do traces and metrics and tags. Longer term, we're looking at other types of telemetry, whether those be logs, profiles, errors, anything else, and we'll be adding those into OpenCensus as we go forward. I think that's it. Yep. So if anybody has any questions, we're up here and we can answer those. I think we still have some time left.
Yeah. Well,
5 minutes? Yeah, so we can do 5 minutes of questions on stage, and then we can do questions in person after that.
Very nice presentation, thank you. So One of the questions that comes up is, I mean, if you're tracing across the internet, would it be possible to have this intelligence built in middle boxes also? Like middle boxes, say a firewall or something.
Yeah.
Right? Which is necessarily not microservice, but kind of leverage this framework.
Yeah, and so the question was, how do we do tracing if there's something else that you don't own that's in the way, so like a firewall? And just to clarify, do you mean how do we make sure there's a complete trace, or are you more interested in getting metadata out of that component?
At least minimally metadata, because
Okay.
there is a latency bound, right? So you want
Yep.
to make this latency critical app I'm trying to access.
Yep.
But I want to find out what the bottleneck is. Not
Yeah.
necessarily. It could be somewhere in the middle.
Yeah, so there's a number of things that we're doing. So just to ensure that the trace is complete, there's the trace context working group, which we actually kicked off about a year ago, just to make sure that like any third-party services don't strip any trace headers out. In terms of getting metadata out of that, there's a few different opportunities that we're looking at in terms of maybe propagating some kind of metadata along with the context that would at least give you like the network time versus like the compute time, for example. Beyond that, we've been sort of ping-ponging around the idea of like sort of standardized APIs for tracing that can send data, like sort of web APIs that can send data to a back end. But we don't have anything that we're like working on like right now for that. It's a pretty tricky problem, especially when you're dealing with so many different vendors of different appliances.
Yeah, this is a hard one. I mean,
Yeah.
How do you get?
Yeah. There's a reason like no one's really done that yet.
How do you like get your routers and switches and firewalls and like those?
Exactly. I mean, there's been some work going on in IETF, but this
Yeah.
is very nice to sort of at least have.
Yeah, so I think in the industry
Yeah.
there is, in general, a gap between application performance measurement and like network monitoring. Like the two have never really met in useful ways, and they should. But
I think as you see adoption of like OpenCensus through other cloud vendors, which is something we're working on, at least when you're in their environment, you might get more metadata back because they control that. But in terms of like embedding this support into like third-party like switches from, I don't know, Cisco or someone, that's a whole separate conversation. Yeah, hopefully.
When you're transitioning to the virtual net, DNS.
Yes. Yeah.
Right. We can talk more about that's an interesting.
Any other questions that we could answer? Aha, yeah.
I have just one small question. I mean, it's about resource consumption in cloud environment. Is it going to affect the environment?
Yeah.
Is it going to make it cost a lot more for an application?
Yeah, so the question was about resource consumption for OpenCensus and just in general capturing telemetry. So in general, the resource consumption of OpenCensus is effectively zero or negligible. This is part of the reason that we sample traces. For example, if you don't sample traces, that becomes, like the resource consumption becomes more obvious and more measurable. But no, like in general, OpenCensus, as well as just speaking just from Google and Stackdriver, any of our telemetry collection technology aims to be like basically no impact. Frankly, technologies like this aren't necessarily that useful if they're going to start running up your bill or making your application perform more slowly, right? And like the goal of these is that you can run them in production safely with no impact. And like for reference, like internally at Google, like this stuff is all there and it's running, and we get both minimal impact from it and also the value we extract is huge. So it's definitely important.
It's obviously not zero. I mean,
but it's
But the point is value trumps whatever resource utilization, consumption, and corresponding bill. So
yeah. That's a good question. So OpenTracing defines an API for collecting traces from, and there's a community around that. OpenCensus defines, of course, an API for tracing metrics and other telemetry, and also has the implementation. The APIs for OpenCensus and OpenTracing, while similar, are not identical, as many people often point out. I believe we had a pull request from the community that added, so not changed the existing OpenCensus API, but added support for OpenTracing as well. I think we either accepted that or we're about to. So while the APIs, at the moment, we've had a lot of conversations with Ben and the OpenTracing community. At the moment, it doesn't seem like the APIs are going to converge, but we do have compatibility for it. And if it's, I don't know if the pull request is like done or not, but it's in review and it's going to happen. All right.
All right.
I think we're done. Thank you very much for coming.
Thank you.